Hi, everyone. Thanks for tuning in to the Printed Circuit podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. In this episode, we'll focus on electronic co-design with regards to cables and harnesses. Here to join me in this discussion is Erica Van Berkom, leader in product management with Siemens. Thanks for being here, Erica.
Thanks for having me, Steph.
Can you give myself and the audience a brief introduction of your background and what you bring to the table for Siemens as well as the industry?
I started my career over 20 years ago in wire harness design. Spent some time at Yazaki, so the world's largest harness supplier. Spent some time at Nissan, also started there in wire harness design. Moved to some various roles in electrical and vehicle program management. I've been with Siemens now over 5 years. Started helping customers do large-scale deployments of Capital, or our integrated electrical solution software system. And most recently, for the last 2 years, I've been a leader in our Capital, or integrated electrical solution product management team, representing our connectivity domain. So if you think about where that sits, that's in between like systems requirements design and harness design and manufacturing, where you would transform your logical designs into your physical designs.
That's a lot. And when you think about it, that's a lot. And I'm really excited to get in this dialogue with you. So what are the key challenges for electrical or electronic designers that are working together when you talk about co-design?
I think it all stems down to silos. I think we see this everywhere, where we still see a lot of people working in silos. And what does that really do? That causes a lack of visibility of changes, both upstream and downstream in the design. The information isn't coming as consistently as it should, or as frequently as it should. Also, they don't understand how those requirements are implemented across different domains, like electrical or mechanical or software. So if I stick in my harness side brain for a second here, if I think about all the mechanical engineers that would make a change to their component, they move it slightly, or they move a connection point to a harness, and they think that doesn't impact me at all, but it impacts your routing and your wire length and your voltage drop and a possible EMC, EMI, right? So how do you get those teams really communicating with each other? And then that lack of visibility to the kind of system level functional design. So instead of me just designing my harness for the lowest weight or the least cost, like what's the whole vehicle doing? What's the overall performance look like? And how do we break down those cycles?
From my experience, the silos are the biggest issue that I see is the manual effort of collaboration, where the human error, the human potential for error really is amplified because of the fact that we are, in the past have been working in silos. From what we see in the capabilities of the tools today and what we have in the ecosystems today, it's a challenge. And you make some great bullet points there. So can you tell me, how can electrical and electronic designers overcome these challenges?
I think there's two main ways they could overcome them. I think first would be tools. On the tool side, you really need to kind of visualize and understand the implication of those requirement changes on those downstream designs like electrical and electronics. That traceability is vital for our safe and secure EE systems designs. So it allows you to get out of those engineering silos where engineers make good decisions into the implications of that wider or broader system that you have. And I think also the ability, again, if we're back to a tool, that ability to do architectural trade studies is really important, right? So you can understand the system implications of change, but also when implementations are done at the design level, how do you back propagate and feed those back into the architectural design, right? And how do you do that sooner in the design process?
I couldn't agree with you more. And I just want to amplify. When I think about all that you're saying, it's basically, how good is your digital thread? How is your communication? Are you communicating, and when? And what is that visibility of the efforts that are going on as the collaboration happens?
And the speed of communication.
Is it instantaneous? Is it a day, 2 days, hours later? I mean, you're spot on with that. And you're preaching the gospel. I couldn't say more. And when you think about our legacy approach, and the sad thing is that the culture of this that still exists of, I don't want to make the change because I'm okay with the level of success we're having. And it's good enough. That's good enough for us. But when I see that companies are leaving money on the table by not evolving with the tools, evolving with the industry, with its capabilities, to me is disconcerting. I find it very difficult to understand. But I do know that from my experiences is it's not easy to make change, especially when we talk about culture's changing and making a change in the ecosystem when, hey, we have been having success, as you mentioned, the silos that are going on. It's definitely a challenge.
I also think a little more interesting and kind of complicated because you have the same leadership structure under the electrical and the electronics typically, right? So your point, it's like they have the ability and the power to make some sweeping changes here, but yet they choose to let their business units or some groups just kind of operate in the systems they've always done because they're comfortable, they're used to the software, or I knew this guy that worked at this thing and now we use this process. And again, how are they really challenging themselves to get to that next level?
Yeah, especially when you think about the younger generation coming into the industry that are, I don't want to say corrupted, but they're not contaminated in a sense. They're coming in raw with maybe some fresh ideas, just a new idea, a new look, and a new perspective. But yet the old guard is in place. And it's like, no, this is the swim lane you stay in, and this is how we do it. We've been doing this for 40 years and been very successful. But that success, if you stand back and take a bigger picture of it, the success could be that much more if you were to be more open to the change or the evolution of today's integration between the different domains from mechanical to electrical, or from the different silos from the different disciplines within the when you think about the system design to include the cables and harnesses. That it's important because those signals, when they leave the circuit board, they got to go to the outside world. And how are they getting there? They're getting there through the cables and the harnesses, whether it's a true rigid cable, or if it's a flex cable. I say rigid, but it's a cable with wires, or if it's flex. When you think about automobiles today, they're like filled with flex. Aircrafts are getting the same, where it's more and more flex, and it's quite the challenge. When we talk about the electrical and electronic codomain, and then you add in mechanical and systems, it's quite the challenge. Tell me, Erica, from your perspective, what are some of the roadblocks that we're seeing regarding these type changes?
I think you hit the nail on the head stuff. Like change is hard. Change is hard. It doesn't matter where you're doing it, right? At work or outside of work. And a lot of people are resistant to change. And I think, your engineers, they show up every day to work and they want to do the best job they can do and they want to be very effective. And, when you're rolling out change, you've got to manage that balance. You are going to see a dip in productivity as people scale up and they go through this change. But I think we're back to those. If the leaders are communicating clearly, like the why we're doing this, what's the value proposition, what are we going to get out of it? Is it 5% growth, 10% growth, reaching this next level? If you communicate that why and recognize you're going to be patient with your team as they go through this dip in productivity, and how do you make that dip as short as possible and as least painful as possible, then I think you can have some success. And I think what we see some of our customers do is, proactive training, or they do pilot programs, or they have SMEs who become, or subject matter experts who become black belts to partner with programs as they kind of roll out through the change process.
Yeah, I tell you, from my recent experience, within the aerospace industry, the biggest hurdle was when it came to change. I'll say one of the biggest is that who's going to pay for it, and this customer on this project, the project manager is like, "Okay, I'm not paying for that change. I have my budget for my project, and I want to stay within its target as best I can, and I don't want to pay for our company to change our internal processes." And then at the same time, the end customer is like, "Hey, I'm not paying you to improve your processes. I'm paying you to deliver my widget to me, the best product, best quality with the highest yields, lowest cost." They're not looking for you to evolve yourself. So the question then is, how do you get past that hurdle of implementing change? And then, of course, who's paying for it? And a lot of resistance I've seen is, we're not going to do that change on my project because I don't have the budget for it. Therefore, you blink your eye, 5 years go by, 10 years go by, and you're still doing the same way, the same iterative, same silos, same manual effort. Then you may have success, but it's success because you probably have a few team members who are going above and beyond and making sure that everything is successful. What happens when they leave the company, or they go out sick, go on vacation? Then it's a single point failure. That success is no longer there. When I think about our co-designs for electronic and electrical, that's the key.
Yeah, they don't want to pay for it and they don't want to be the guinea pig, right? Nobody wants to go first.
Yeah, no, I agree. I'm curious, when it comes to the cabling, is there anything specific that is a hurdle, the cable and the harnesses that we see as part of, roadblocks of change? My evolution, my world is like mainly in board design, but it's beyond board design. We think about the system and the cabling. A lot of people don't know how to handle that. They don't know how to address it.
Yeah, we see a lot of similarities. Like I think throughout our industry, our core industries are automotive and aerospace, right? I mean, we do have others, but I think those are the kind of core of where we spend our time. And I think they're all trying to do the same thing, though their speed of change is slightly different. I think when I first started my career in automotive, our design development cycle was, maybe 4 to 6 years, right, for vehicle design. And now we're like a year and a half to two. So how do you do that? You can't do that. You can't physically get to the point where you're building harnesses and you're testing them on a breadboard. You have to, again, have that digital twin because you have to do this electronically. You have to do it earlier. You have to have a shorter feedback cycle. Auto and aerospace, from my standpoint, they're trying to solve a lot of the same problems. They feel like they're so different, but they really are trying to solve the same problems here.
I agree. Especially, when you think about at the enterprise level of whether it's aerospace or automotive, they're big machines that, when I say machines, that function like big machines. So how do you, affect change, or how do you use the digital twin or the digital thread? And I think the key is, what we said in the beginning is, and what you outlined is, you got to have a solid digital thread at the very beginning from when it comes to the requirements, locking in the requirements from your customers through your end product of delivery. And then with locking down that digital thread, then that spawns the digital twin as it starts evolving to be able to do the different analysis. And you said it best about how do you adapt to change, and why you changed it. What is the why? Why did we do this? Why did we go in this direction? Or why did we pivot and go in a different direction? And I think that's key to having that co-collaboration between the different disciplines and the different domains, and having the tools in place to be able to do that. And I think that's what Siemens, brings to the table as a solid solution, being able to be extremely successful in that ecosystem of going from domain to domain very efficiently and very effectively. Would you agree?
I absolutely agree. And I think one of the things I've seen our most successful customers in implementing this change is by implementing small change and building your foundations. So, I mean, like, are you training users? Are your libraries set up? Because that's always a big failure. Are your libraries? I know you guys are into the PCB world too. And then we all understand the value of the Siemens Accelerator portfolio and everything we offer, but we don't have to. How do you eat the elephant? It's one bite at a time, and you can't eat it all at once, right? So how do you break up that change and still show success at each milestone along the way, and just build success on small success on small success, and not try to just do it all at once, because then it's too overwhelming for people to consume.
So, Erica, let me ask, what are the best practices when it comes to cable and harness design?
Capital has a great solution. And what I like about Capital is that it does exist really well and integrate well with our tools in the Siemens Accelerator with other MCAD or ECAD or PLM systems, right? But it also plugs and plays with we have a lot of tight, data and integrations and bridges to other tools, right? So if you are a CATIA house, as an example, you can still use Capital, right? So you kind of have we have these standard file formats that we can import and export. And then of course, if you're using Capital or Siemens Accelerator for us, then you have the digital twin, right? So it's like, what are you doing to enable that thread to eliminate that manual entry and to have the reuse of data, right? So you're really saving time and building that efficiency. So you're spending less time in the tool and eliminating human errors.
What I love about the Siemens solution is that you see the change instantly, or the potential for change, and you can address on the fly changes or on the fly suggestions. You can do some what if scenarios, and allows the full team to interact instantaneously versus, hey, I'm going to make this change and I'm going to email it to you, or I'm going to put it on a server somewhere. Then you got to grab it, and then you have to import it into your system. And it's just time consuming. And when you think about the evolution of today, of how quick can you get to market with the least amount of effort, as well as the least amount of expense with the least resources that we're up against, the challenges in what the project teams face today, it's challenging.
Like we talked about earlier, you kind of have to get the engineer out of thinking about just their widget, right? Now it's the whole system. What are you doing that's best for the system and not just for your widget? So then having this digital twin and using Siemens Accelerator really makes a lot of sense to ensure you're doing just that.
I couldn't agree more. And I can tell you, when it comes to working on projects teams, project visibility to everyone of who's doing what, when, and what are the reasons for decisions being made, and having the ability to look back and say, why did we make that decision and go down that path is extremely important. So it's key. When I talk about the co-design and the multidiscipline integration and collaboration that takes place. So tell me, are there any differences in how the different industries approach this aspect, especially when we talked about automotive and aerospace?
I think there are subtle differences. I think in terms of course, how they physically put the cables in their respective vehicles is really different, right? I think aerospace is a lot like marine. They have these massive, super long cables, whereas, the automotive industry just things a little compartmentalized, right? But I see a lot of them following the best practices and really leaning towards like a generative approach. Like, what can we do that's more automated, more intelligent, and less manual, sorry, rather than keep doing the same thing over and over again? And how do I reuse that data? That's what they all want to know. How can I want this piece of what I did before and this piece of what I did before, and how do I merge this all together seamlessly, right? And not have to re-enter all this over and over and over again. They're all doing a lot of the same challenges right now.
I know that there are customers who are not willing to pay for engineering teams to redesign the same thing they've been doing. Like, for example, whether it's a cable or whether it's a power supply, they don't want to pay for you to redo it, to redesign or reinvent the wheel. Why can't you use the system, what you did before last time for me? Or a company, internal company can say, hey, let's use this cable from here or this widget from there, and let's bring this and take advantage of reuse in today's tools. That's the difference in that. But, we talked about, resistance to change. You'll be surprised how many people are redoing that stuff manually because they're not utilizing the horsepower in their tools, which Siemens Solutions is amazing at what they offer for when it comes to design reuse and the capabilities that are feature rich in our tools that allow us to utilize, today's leading features to allow us to be more efficient and more collaborative in our approach to successful design, whether it's in one aspect or another, or we talk about the full electronic system in itself. So it's definitely that much more. Is there anything else you may want to add to that, or would you just basically agree and say that's?
Yeah, I absolutely agree with you.
All right. I think we've outlined the best practices when it comes to electronic co-design. And as Erica pointed out, the key is communication and breaking down the silos. Erica, I think you said that right from the beginning. I think that's key. And so I can't thank you enough for joining this conversation. It's been very insightful, and it's really, really great content when it comes to how we are doing things today and where we need to be going and continue going forward. And if you're not, I will tell you, your team will eventually be left behind. That's for sure. So, Erica, thanks again for your invaluable insights.
Thank you for having me today.
So, again, thanks for everyone to tuning in. I hope you tune in to our next episode where we talk about FPGA and PCB co-design.